All right, so we're going to take a look at simple interest versus compound interest. So we've talked about compound interest. We're going to include what simple interest is. Simple interest is just like a linear function, and we've looked at compound interest, which looks like it's an exponential function. All right, so we're going to look at two different scenarios. So account A earns 10% in simple interest per year. Okay, so it's shown here in the table. Here's a graph of it. How is the balance changing from year to year, and how did you find it? And you'll notice that this is a perfect straight linear function. All right, so how is the balance changing from year to year? So how do I go from 500 to 550, 550 to 600, 600 to 650? Well, you should notice that I am adding 50 every time. I add 50 to get to 550, I add 50 to get to 600, then I add 50 to get to 650. So if I just continued this pattern and added 50, 650 plus 50 will be 700. Then I add 50 again, and I would get 750 because this is a constant rate of change. How is the balance changing from year to year? It is changing by adding 50 every year. How do you find it? Okay, so intuitively, you could just look at this and see it. But sometimes the numbers are not that obvious. So I'm just going to make sure that you understand how to find it. Because this is a constant rate of change, what you do is, and again, I'm going to show you this in a formula real quick. All right, this is your slope right here, y2 minus y1 over x2 minus x1. And I'm going to put that in the calculator. And the reason I'm insisting on doing this is because sometimes, you see how this is going 0, 1, 2, 3, 4, 5? It's in order. Sometimes they don't put it in order. So I'm going to actually show you that it's going to be the same thing. So you already know this, parentheses minus parentheses over parentheses minus parentheses. Now, according to the formula, your second value of x minus your first value, and then your second value of y minus your first value of y goes on the top. So this x is on the bottom, y is on the top. All right, so going back to that, my second value of x, so this is my first x, so this is x1, this is x2, which would make this y1, y2. All right, so my second x values goes on the bottom, which is 1, my first one on the top, which is 0. And if you notice, 1 minus 0 is 1 because this is changing by 1 every time. It's a consistent rate of change or constant rate of change. When x is 1, y is 550. So when x is 1, y is 550. When x is 0, y is 500. And you'll see that will give me the same value of 50 because what we're doing is this change right here is we're adding 1 each time. This change is we're adding 1 each time. This change we're adding 1. So when you do the change in y, which is 50, divided by the change in x, which is 1, 50 divided by 1 would still give you 50. And that's why we're just able to quickly see it because this is a constant rate of change. So how did I find it? I used my slope formula, okay, just in case they give you ones that are not the same. y2 minus y1 over x2 minus x1. And what was that? 50 over 1, which is equal to plus 50. How does that prove that it's linear? Okay, how does this prove it's linear? It has a constant rate of change when you take the first difference. Okay, so first difference is constant. Okay, what that means is whatever you're adding or subtracting every time is the same exact number. All right, let's write an equation for the function. Okay, we're trying to write a linear function. I don't remember how to do that. I'm going to go find it. It says linear equation in slope-intercept form is the one that we worked with the most. We have y equals mx plus b. So I'm going to go ahead and write that down. So I have y equals mx plus b. And again, you see m. What's m? M is this slope right here, y2 minus y1 over x2 minus x1. So m is your slope. Okay, and I'm not going to write y2 minus y1. And then b is your y-intercept, or from a table where x is equal to 0. So how would I write this equation? Well, I could just look at the information that I have. So I have y equals, all right, what is my slope or my constant rate of change, or y2 minus y1 over x2 minus x1? It's 50. So I'm going to write 50. And then what do I have next? I have x. So I'm going to put an x. And then whatever b is, and if I look at b, my y-intercept, or where x is equal to 0. So if where x is equal to 0 is my y-intercept, how I started off, which is 500. So this is my equation. Okay. So that's how you write an equation given a table. Again, you can use a calculator, and I'll show you that in a later video. And I did forget to mention simple interest. Interest is not included. It's only calculated on principal. What do I mean by that? It says 10%. If I take 10% of 500, you're going to get 50, which 500 plus 50 is 550. If I take 10% of 550, it's going to give me $55. But you can see I'm only adding 50 because it calculates interest on principal only. It is not included in the interest. All right, now the difference being that when you're doing compound, interest is calculated on principal and interest. So it's calculated on the principal plus also the interest. So it would have been, in this case, if this was compound, it would have been 10% of 550, which is $55, and not 10% on just the 500 principal. Account B earns blank percent compound interest per year. How's the balance changing from year to year, and how did you find it? Okay, so I'm first going to start off thinking maybe it's a linear function. Okay, so what do I do with a linear function? I do y2 minus y1 over the rate of change for x2 minus x1, and I should get the same number, so I'm going to try it first. This is x1, this is x2, y1, y2. So when x2, which is 1, minus x1, which is 0, and then here, 1 goes with 525, and 0 goes with 500. All right, so it's saying that it changes by 25, which looks like it's right. 500 plus 25 is 525. So let's see if it works all the time. So when I go 525, which is now this number right here, and then I add 25, do I get the next one? No. So this is not a consistent or constant rate of change, so it's not linear. So the next thing I'm going to check if it's exponential. Okay, how is it calculated? Remember, you take your second y value, and instead of subtracting it, you divide it. So it's your second y value divided by y1. And we're going to check to see for successive x values. So this goes 0, 1, 2, 3, 4, 5, so that works. All right, so I'm going to take my second y value, which is 525. And it doesn't matter which one, as long as they go in order. So you see I go 3, 4, I can use this one and this one. But I already started with this one, so I'm going to keep that. So my second y value divided by my first y value, which is 500. So now it's saying that each time, if this is an exponential function, I should be multiplying this by 1.05. So let's see if it works. I start off with $500. I multiply it by 1.05. I get the next number. All right, so now I'm going to check to see if I multiply the next number, which is 525 times 1.05, do I get the next number? I do. If I take that number, which is 551.25, and I multiply it by 1.05, do I get the next number? I do. If I take that next number, which is 578.81, multiply by 1.05, do I get this next number? I do. And since I want the fifth one, I'm going to go ahead and just do that while I'm here. So this is going to be 607. Oh, I lost it. 0.75 times the next, times 1.05. So this one is going to be 638, and it's since it's money, I'm going to put it in cents, which is going to be 14. All right, so what am I doing each time? I'm multiplying the previous number by 1.05, multiplying by 1.05, multiplying by 1.05, multiplying by 1.05. All right, now you should be able to tell me, if I'm multiplying by 1.05, what is my percent? Pause the video and do it real quick. All right, you should have said it will be 5%, because to go from percent to this number, you would take the percent divided by 100, and then you would do, because it's growing, 1 plus, and you'd get the 1.05 back. All right, so now that I know that, how does it prove that it's exponential? Because I am multiplying by the exact same thing each time, in order to prove that it's exponential, we're going to say that the ratio of successive y values are constant, or you can say the same. All right, what that means is it's always 1.05. All right, now that you've done that, write an equation for this function. Well, I know since I'm multiplying each time by the same number, this is a exponential function. So we're going to start off with, what is an exponential function? Let's go ahead and find it. Quadratic. Here's an exponential function, and we've done a lot of that. So we know that y equals abx raised to the x power. Okay, that's my exponential function. Now I just need to put the numbers in there. So what's my A? My A is my start, which is at x equals 0, which is 500. So I'm just going to replace this one with 500. And then my B, how is it growing each time? It's 1.05. And then my X is my time. Okay, so this is my function. To make sure that I'm right, I'm going to turn it into a table. So I'm going to click gear, table, and then we're going to make sure that the numbers I have, so I'm going to press enter until I get to 5, are correct. Do I have 500, 525, 551.25, 578.81 rounded, 6.07.75 rounded, 6.38.14 rounded? All right, perfect. I do. So this is the correct equation. This is going to be y equals a b x. All right, and I'm going to kind of squeeze it in here. A is initial, where x is equal to 0. B is my growth, and x is my time. Okay, so what does that look like? Y equals my initial, which is 500. I'm growing by 1.05 each time, and my time is x. So this is my equation. All right, so what you're going to do is just go ahead and tell me which account would you prefer and why. So you're going to look at these two tables, okay? Which one would you prefer if you had started off putting 500 in a bank account? Which one would you prefer and why? Let's practice.